Hello. All right. Welcome back to Advent of Code with me, Lian. So in case you don't know me, my name is Lian. I'm a developer advocate with Loft Labs. I used to be a software engineer. I used to be a web developer, I think we call him now. And I don't get to write a lot of code anymore. So things like Advent of Code or coding games or stuff like that is super awesome because I can get to train my coding muscles and so I don't forget how to code. So yesterday we started on the first puzzle in Advent of Code, and in case you don't know, usually, or I guess every time, you get 2 puzzles per day. And then you get the second puzzle only after you finish the first one. Usually the first couple of puzzles are fairly straightforward and they get progressively harder. So I think I made it until day 16 last time, and then usually the limits are, computational limits for me because I just they didn't find the most elegant and simple way to solve the problem, and then the only solution I could find was like I had to brute force things, and so they either took very long or I just ran out of memory. Anyhow, we are way not there yet. We are still on day 2, and because I'm trying to do this every day, but sometimes life gets in the way, and so it's a daily stream unless I have something better to do. So we're not gonna always be 2 days behind. Some maybe in the in a couple of days we might be 6 days behind because I have to also visit my family. So without further ado, let's go and look at the exercise for day 2, which was Friday, I think. Rock, paper, scissors. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to this next storage, a giant rock, paper, scissors tournament is already in progress. So, in case you forgot, we are trying to find the forest that has star fruit because is it the reindeer that run on star fruit? Oh, we need that as to power ourselves for Christmas, to be able to distribute all the presents, something like that. So we're on an expedition, and right now we set up camp on the beach. Rock, paper, scissors is a game between 2 players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play: A for rock, B for paper, and C for scissors. The second column, and suddenly the elf is called away to help with someone's tent. The second column you reason must be what you should play in response: X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. And the score for a single round is the score for the shape you selected, 1 for rock, 2 for paper, and 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you're given the following strategy guide. So this is our test input, right? This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock A and you should choose paper. This ends in a win for you with a score of 8. 2 because you chose paper, 6 because you won. In the second round, your opponent will choose paper and you should choose rock. That's an X. This ends in a loss for you with a score of 1. The third round is a draw with both players choosing scissors, giving you a score of 3. of 6. 3 plus 3 equals 6. In this example, if you were to follow the strategy guide, you would get a total score of 15. What would your total score be if everything goes exactly according to your strategy guide? So, first of all, hey, Pradumna, nice to have you. Nice to see you. So, as I explained yesterday, in the Advent of Code puzzles, you get a test input like this with just a smaller set just to get you started, and you can use that to develop. And then later in the game, you get your actual test input, which is much longer, and maybe we'll cover some edge cases. And this puzzle input is also different for every single account. So I can't just like copy your answer. So yeah, we can now just copy and paste this, and I will do as I did yesterday. I will create a day2 test input file, and I will read from that file. Just so it's the same with the test input as it is with the other inputs, with the final puzzle input. And where did it go? Yeah, and this time around, if you remember, I intended to write unit tests. The reason why I think even here, the unit test, even if we have like pretty small units that we're developing, they're super helpful if we're refactoring stuff. So I did it yesterday. I did it today when I solved the current Advent of Code puzzle. Day, I want to say 4. Is it 4 or 5? Something like that. You start off with a solution, and maybe it's like you're just writing everything out, and then you optimize for things, right? Maybe you will use a more elegant algorithm, or you will just like shorten some stuff to make it a little bit more, one-liney. And when you do that, you need to make sure that your algorithm still works. And so having a test just makes it a bit easier because you don't have to compare numbers. You just like let the test algorithm do that for you. It's just like a slight convenience. So, and then maybe for some people, it's also interesting to just see how we write a test and how we develop test-driven. So I'm going to create this test.py file. And I'm not an expert on unit tests, especially not with Python, because I haven't actually written any Python code in production or for production. And following that, I also did not write any tests for production. But I have played around with it a little bit, and I've definitely written a lot of unit tests in JavaScript and PHP and Java. And then the other thing is that I have GitHub Copilot running, which is a service by GitHub that will give you AI-generated autocompletion suggestions. And yeah, we talked about this briefly yesterday about like, is it valid to have AI solve your puzzle or parts of your puzzle? And I think, well, not that we came to agreement, I came to agreement with myself that as long as you're not influencing the leaderboard, it's totally okay. Do whatever you do. So yeah, you will see these kind of suggestions pop up once in a while, and that's probably GitHub Copilot suggesting some stuff for us. So we to run unit tests. Oh, this is amazing. So to run unit tests, we have to create a class, and this is how it will look. So we create this class. It's called test day2, sure, and then we want to test the first part. So there's always 2 parts to the puzzle, right? So this is the test for the first part. And then we can call on self. So this is the test class passing itself into this function. And so we can call assert equal to make a comparison between 2 values. And in this case, I know that the result at the end is 15. So this is the thing that I want my function or my test, my algorithm, my solution to give me if I give it this input, right? So in a test, I would say, I expect this to come out, and I am asserting that this number is the same as the return value of my solution. So first of all, I have to create that file. That's day2pi. And I have to import that. And I'm going to create a function here that will return, I'm going to return 0 for now. So now that I've imported it, I can call day2.part1, call it. And so one thing is, of course, I could just let it return 15, and then my test would be green. It's not green yet because I have to, I have to tell the process to actually call that test when I execute this Python file. So if I do this now, I will probably get a positive test, or I will get nothing. Okay, so now I get a positive test, and this tells me nothing. First of all, I don't even know if my test setup properly works. Maybe, I don't know, some fluke. Second, we didn't implement the solution, right? So one thing in test-driven development is you should always start with from a broken state. You should always start returning something that you know is wrong, and then expecting the test failure, just so you know that the test is actually asserting correctly what you want. Because maybe if you accidentally return true somewhere or something, then it just says okay, and you never find out that your test was actually broken. So, okay, so we want to start from a failure situation, and now we have a test. And every time we write some code, we can just call the test, and then we will see where we are. So what is the actual, I already forgot the actual exercise again. We've given this, this is rock, paper, scissors, I remember now. So we know that ABC is rock, paper, and scissor, and XYZ is also rock, paper, and scissor. So one thing we need to do is we need to find out who wins. So in any kind of these combinations, we need to be able to find out a winner, a loser, or a draw. So what we should probably do first is we should load the file. And if you remember yesterday, I already created like a function to load lines from file. And I'm just going to call this read from file. And we're going to pass in the string day2test. Why am I typing this like some kind of peasant if I have GitHub autocomplete, GitHub Autopilot, Copilot? Okay, so this should be my input, and that's just, we could, you know what, instead of just printing, we could just return the input, because now we have a test wrapping this. So now if we run the test, we should get, assertion error, because 15 is not this, and we know now this is the output of this function. So this is a way that we can like look at stuff without actually printing things all the time. All right. So we will not return from here. This is our input now. And now we have 3 elements with 3 characters. This is the one that I think your opponent is playing. Then we have like a space, and then the second one is the one that we're playing. So we need to split those up also, so we can evaluate each of these letters by themselves. Yeah, your opponent will. So yeah, the first one is the opponent. I just wanted to make sure I got that right. So one way we can do this is probably the same in almost every language, is that we should probably want to split on the space. So one way that Python can do that is we can iterate through a list really elegantly by using list comprehensions. So we can iterate through this list now by saying, so we want to do something for each line in this file. And for each line in this file, what we want to do is we want to split it. And we want to split it on this empty this space. So I'm just going to return again so we can look at this. Yeah, and now we have a list in which holds 3 lists in which we have these letters individually, which is pretty awesome. So already now we have this input transformed in a way that's really useful to us. So now we need to figure out who's winning. So A is, A is rock, paper, scissors. And like autopilot even knows that it's rock, paper, and scissors. Wow. Is it just gonna like do this for me now? I have so many people that I've been of code that Copilot just now knows. Oh my god. Wow. Oh Jesus. So this is Copilot just knowing the rules of rock, paper, and scissors. Wow, okay, that's amazing. I did not expect that. I should maybe try if I do lizard and spot. Oh my god. So does it know these rules as well? Oh shit. Oh fuck. Oh my god. This is hilarious. Okay. All right. This is without lizard and spark. This is just the regular ones. And I think there's, yeah. Okay, but this is also, funnily enough, this is also part of the exercise, right? Rock gives me 1 point. Paper gives me, oh no, rock, because I chose paper. Okay, so for me, it's like rock gives me, you choose 1 point, paper, 2 points. Yeah, here, 2 points because you chose paper, and then 3 for scissors. Oh my god, that was a bit scary, I have to say. All right. So as I was saying, in a situation where this is rock, paper, scissors, and then we do X. Oh my god. Okay. How do we know which one beats which one? So let's see, Copilot. I will be able to do that. So if I do X beats C, it's close. X beats C, and then Y beats A, and Z beats B. Is that right? Rock beats scissors, paper beats rock, and scissors beats paper. Yeah, that is right. Okay. I guess we don't need this one, but we do need just like X equals, yeah. Oh Lord, now I understand why people are not happy with AI solving this, because I haven't really thought about anything yet. Okay, cool. So this is the setup. This is the stuff that we know. And now we have to find out, how do we algorithmically implement this logic? And then we have to also implement this logic and basically add the results of these 2 things together. Because then we also have this thing where a win equals 6 points. It's close because it's not lose 3, it's tie 3. But I bet if, yeah. Oh no, loses. Okay. This is a different game now. All right. So how do we algorithmically implement this thing? I mean, we can do it. Let's start with a simple one. Let's just say that if okay, first we have to iterate through all the lines in input. So for round in input, if our opponent, which is, let's just write things out for now, and we'll optimize later. The opponent is round 0, and you are round 1. If the opponent plays A, and you plays Y, then we win. And you win. Or if the opponent, oh my god, okay, this is gonna be a super short stream because I'm just gonna let Copilot do this. But let me just check if this is right. Okay, so if the opponent plays B and I play Z, I win. And then if the opponent plays C, I mean, I told it everything it needs to know, right? I would be surprised if it wouldn't understand how this is implemented. Okay. So, okay, when we win, we need to round up, we need to calculate our scores. And then I'm guessing I'm calculating the score for each round, and then I'm guessing I will have a total score. So I'm just gonna put in score 0. And then when I win, I will always have a score for the thing that I'm playing. That's always a set. So I can do that even before I do the check. So I'm always going to do score equals or plus equals, which means I'm adding the number to the score and then I'm assigning it to the score in one go. So XY, so I'm going to do, I could also do if u x then plus 1, but I'm going to use a dictionary here. Points, I'm just going to say points. So a dictionary is basically, it's an object that maps a key, which in this case is x, to a value, which in this case is 1. And then I can have a lot of other elements that follow kind of the same pattern. They don't actually have to follow this exact pattern, I don't think, but yeah, it doesn't in this case. So what I then can do here is, first of all, this will stay the same throughout this entire thing, so I can just put it in here. So otherwise we're going to regenerate it every time we go through this loop. So here, as I said, we always have to add the points. So we're just going to do points u. So what it does is u is a letter, right? U is X, Y, or Z. And then we're just going to do a lookup in this dictionary, and then we will add this number because we're going to get this number no matter whether we win or lose. And then when this happens, when we win, we will add plus 6, I think. Yes, 6. Okay. And then when we've done that, we will then return the score. And so I hope the chat is still with me to know that this, will it fail? Will it succeed? I know that people are watching. I can see that you're still watching. It will fail because we only calculate the wins and not the ties. And also this is kind of not elegant. So what is another way that we could do this instead of just comparing A to Y and B to Z and whatever? One thing that we could do is these already have numbers, right? X, Y, and Z already are numbers. And with the exception of rock and scissors, basically, we can shift by one number, and then we can basically use math, more or less. So what I mean is that if A is rock and A is 1, all right, okay, let's start with X, Y. We already have that, right? This one we already have. So if X is rock, what beats rock? Paper beats rock. So if B, which is paper, is 2, then B is already bigger. So we already know that this will beat this because it's bigger. Y is paper, and paper is beaten by scissors. So C could be scissors. Then this will leave us with A equals a rock, which is 3. No, hold up. I made a mistake. Okay, so C is 3 and A must be 1. So with the exception of this situation where Z is 3 and A is 1, we could say that whenever this gives us a higher number, we know that we win, but then this is an exception. Is there a way that we can do it without having this weird exception? I guess we could do like, give them the same numbers. And then we would know if these numbers are the same, then this person has 1. Okay, the first one, oh wait, I'm an idiot. Because the first situation, we already know that no matter what, if now I just want to tab. Okay, if opponent and you are the exact same, that's definitely a draw. So we already have this, and everything else is already an else. This okay. All right, that's not too bad. Already eliminated that case. Holy shit. Okay. Let's get us closer. No. Okay. So we already know. Oh wait, the opponent is never you. Because it's not A, B, and C. It's X, Y, and Z. Not being super smart today. Okay. Yeah. Let's do this with A, B, and C. And then we would do points opponent and points you, and that should now take care of that part, right? And now, because we're only calculating our score, right? We only have to know whether we win or lose, because then if we win or tie, because if we don't win or tie, we know we lost and we don't get any points anyway. So all we need to figure out is how we win, and this is already how we win. So technically, we're already done here, right? It looks not great, but we can get to this later. So let's just see when we get the actual puzzle input. Oh. To input. Let's see if we build something that actually fulfills all the requirements. So in here, I will call part 1. And then instead of, we just pass in the path here. So it's file path, which we get from here. Yep. Oh no. File path. And we have to change that in the test where we call this. See if the test still works. No, because I broke something. Oh, I think I'm calling it here. Yeah. Okay. So now here, I am calling it with just input, not test input. And A2. Oh, wait, I need to print it. Yes. Let's see. My test doesn't print anything. 12772. Let's see. That seems like a reasonable number. Yay! Hooray! That's the right answer. Victory called T. All right, let's check part 2. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. So already we solved for the wrong problem again. That happens a lot, actually. You shouldn't assume things. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above now goes like this. In the first round, your opponent will choose rock, and you need the round to end in a draw. So you will choose rock. This will give you a score of 1. Second round, your opponent will choose paper, and the third round, you will defeat you. So basically, instead of X, Y, Z meaning what we thought it meant, it's the result. Now that you're correctly decrypting the ultra top secret strategy guide, you would get a total score of 12. What would your total score be if everything goes exactly according to your strategy guide? Okay, so we can once again write a test for that. So this is now part 2, where we call part 2. And we know now that we should expect the total score of 12. So close this, move this, and we start on part 2. Look at this. No, that's just copy paste. That's not the same thing. But we could use. Oh, I'm okay. I can just copy paste it from here. It's fine. That's okay. Because we need the same input again in the same way. We're probably gonna do a lot of things in the same way. Should have probably optimized it here before, but if we don't optimize first, just copy paste and then optimize later, I personally feel like it's easier because it makes things much easier to read and understand, even though it's a little bit kind of over the top. But it's easier to copy paste it and then change things and print stuff, if it's just all written out like this. All right. So we do have this same input list again. Let's just run the test. Okay, day 2 has no attribute part 2. Has now, right? Yes, okay, because I didn't save the file. So, okay, we're not returning anything here. That's number 1. So let's return input. Yes, thank you, Copilot. Should probably give my Copilot a name. Octo or something. So now, instead of checking like whether we've won or not, we know whether we've won or not. So already, if we just do this again, right? Oh, yeah, and score 0. That's the good part. So instead of getting these points, what we already know is that X, Y, Z are draw and lose. So X is lose. I'm guessing Y is probably draw. Yeah. So that's 3, and winning is 6. So that we already know. So we can do similar to what we did before. This one always goes. We always if the result, that's not me anymore. We always get these points anyway. And then the only thing is that we have to figure out which letter we actually have to play based on whether we win or lose. So let's see. If so the first round, our opponent plays rock, and we are supposed to tie. That is rock. And as rock, so basically rock, we just need the points. We don't need to figure out what letter it is. So I guess if we go a similar route as we did before, what we would do would be if we have a tie, if the result equals y. Are you listening to me really? Like, how did you know I'm going to go for y first? Then, oh shit. That's exactly what I wanted to do. Fuck. Yeah, so if the result is y, then my point to the point. If the result is, sure, let's say z, I've won. Yeah, because we don't need x, because that's going to be a loss. Oh, well, we still have to add the points to our the letter that we would have played, or the rock, paper, scissors, that thing that we would have played. So if the result is z and we've won, then we need to know, I guess here we could do the thing where we just give it one more, because we know that it's just like +1. Except when it's 4, then it's 1. Okay, that was a bit of a ramble. So if this is, I think, the last scenario. So if our opponent plays C, which is scissors, we need to play rock, which is 1 point again. Yeah. So we need to play, that's almost true. We need to play this. The points of our opponent has +1, unless if our opponent is C, or the point of opponent is 3, whatever, then we add 1 to the score. Otherwise, we add whatever points the opponent has +1. That seems right, right? It's A with 2, B, C, 3, and then, yeah, that seems right. So let's put this use, yeah, I'm gonna get to that in a moment. That is not right. We're missing 1 point. So if, I don't know what exactly the error is, so maybe it's helpful to just print out, probably be good if I didn't just add this, whatever. It's not that much data. We'll be able to figure it out. Print score. So, oh yeah, right. We forgot that we didn't do the, so we have draw, we have win, we didn't do loss. So else, if we lose, then we do the same thing here, except it's the other way around, right? So we'll do, so in here, we would always do -1. Because we need one weaker, unless it's A, and then it would be 3. And we're gonna get to that modular question. So, okay. Yeah, let's just go for it. Let's just try and solve, and then we can make it nice, maybe, if we want to. TXT. 2. Oh, I always forget to print things. Maybe I should just always print it in the function, and then I don't forget. 11,618. Again, seems like a very reasonable result. Woo! Yay! 40 minutes. Well, I was talking a little bit at the beginning, so let's say 30 minutes. Okay, let's go through the comments. Oh, thanks. So first question was, could this use a modular operation instead? It could totally use a modular operation. In a modular operation, what you do is you divide, but the result is not the whatever you call the quotient, I think. It is the return value is actually what's left over. So if you have, let's say, in a situation where you have 2 divided by 1. 2 is maybe not a good example. Let's say 3 divided by 2. In a regular math, it would be 3 divided by 2. In modulo, whatever 3 divided by 2 is, I don't know. In modulo, you will get the result would be 2. Because you can actually not divide 3 by 2. So, wait. What am I talking about? 3 divided by 2 is 1.5. Oh my god, sorry. And then you can divide it by 2 once for a full number. Is that what you call it? Like a full number? Which is just a number that's not a fraction. And then 1 is left over. So 3 is not divisible. So okay, let's go through this again. I'm sorry. It's late. So 3 divided by 2 is 1.5, but 3 modulo 2 is basically, it's not equal, so I'm just going to do this. It is 2 divided by 2, because you can divide 2 by 2, and then you have 1. Right? It's kind of like, it's not really, that's not mathematically correct, the sentence, but you know what I'm getting at. So 3 modulo 2, you get this 1 that's left over. Yes, 3 modulo 2 is equal to 1. So with that knowledge, what we can do, instead of doing this thing where we're basically saying, oh yeah, it's always plus 1 unless z is 3, and then it's unless the opponent is c, and then it's 1 instead of, instead what we could say is we could say it's always modulo 1. So let me work this. So in a situation where we pass in 1, we want the result to be 2. In a situation where we pass in 2, we want it to be 3. Thank you, GitHub Copilot. Now, can you follow me? It can follow me because it already knows in a situation where I have 3, I want 1. This is freaking, I can't get over this. This is scary. So how do we get, what can this operation, this function here in the middle be? So we will get to this result. Yeah, that's a good question. So how do we get this? If we use modulo, basically what we're saying is there's some number here that we're dividing, and then what we want out is that it will add this. This is basically what's left over, and this is the actual, like 2 times 2 or whatever. So if to have 3 even left over, we wouldn't need to, but we don't have to have 3 left over. We actually could always add 1. So here we could just like have a 0 to leave over, and here a 2, and here a 1. So the result, whatever this operation is, we will just always add 1 at the end. So now when we want to have 2 left over, we can divide by 3, because the max you can get in a modular operation, if you modulo by 3, the max you can get is 2. Because if you would get 3, that would be divisible by 3. Divisible. So, listen. If we do 3 divided by 3, that would give us a modulo of 0, right? Because 3, this number, 3 divided by 3 is 1. Here, 2 modulo 3, I'm really bad at explaining this, I realized. 2 modulo 3 would actually give us 2. And then 1, that's the 1. So, yeah, if you were able to follow my rambling, then you probably figured out that we just figured this one out. So, is it? So, yeah, if my opponent is C, because this is the plus 1. Yeah, and then we just have to add plus 1 in the end. Okay, so instead of doing this, we're now saying score, we're adding to the score opponent, points opponent, modulo 3, and then we're adding 1 to it. So now you see, I mean, we could just print it out, but now you see that now I can just run my test, and as long as it's okay, I know I haven't changed the actual logic of it. I mean, I've changed the implementation, but I'm still doing the same thing. I'm still getting the same result. So that's why I like to write tests, even if it's like small stuff. I guess we could do the same here to some degree, maybe. I don't know. Let's find out. So here, when we have 1, we actually want, so what did we originally want? Originally, we wanted to get 3 here, and then 2, we want to have 1 less. So here we want 1 less always, right? So again, we could just remove 1 from all of them and just like add them at the end later. So here we can't use modulo in this way, but maybe we can do it the other way around. What if so we wanted this, right? 3, 1. What if this was not just like the number, but it would be the result of 3 minus something? So in this case, this would be 3 minus 0. And this would be 3 minus 2, right? Maybe 3 is not the best number here. 3. Because we can't use our cool modulo stuff here. So we want to get from 1 to either this. So this is how I write my notes also when I saw this, just, for myself. I just like try different patterns and see if there's something that looks like, oh, this looks like something I can implement, Oh, wait. 0, 1. This doesn't look too promising, I gotta say. This looked like the most promising, but then this is also not exactly what I wanted. The problem is that because it's the other way around, it doesn't follow the same mathematical logic, I guess. It does obviously follow the same logical principles, but it doesn't follow the same pattern, is what I'm saying. Let me see. Okay, let's just take a quick break from this and then look at this other thing that I wanted to improve and optimize. And we can always check on this later. So here we have this, if this wins, then you, and if this wins, then you, and so on. I don't know if this is the best we can do, honestly. Is there a more intelligent, elegant way? Because again, if A equals 1, and we could literally either change So we could just like build another dictionary and just basically say A is Y, B is Z, and C is X, and then we just have to do a lookup. So what I mean is like do this, where A and Y, B is Z, and C is X, exactly. And then all we need to do is basically say if winning opponent equals U. This is basically the same thing. We're doing the same lookup, but again, it's just like written slightly nicer, which I like. So damn, that didn't take super long to optimize. So now I'm running out of things again. So now I'd have to look back here, the thing that I feel like I do not know how to optimize for, but that's okay. That's okay. There's no rush. We can figure it out. So well, we were saying that if my opponent plays A, opponent A is 1. Then I want a 3. And then if opponent 2, so opponent plays 2, which is E, then I want 1. And then 3 was 2. I think it needs to be something like a negative or reverse modulo, probably. So what is PyMaster suggesting? Try starting with points opponent minus 1 modulo 3. Yeah, that seems reasonable. So that means that here it would have 0 modulo 3, which would come up to 3. And then we have 1. That seems like a reasonable suggestion. Yeah, so the thing is that this like +1 and this -1, we have to obviously fit it in somewhere, and then I just tried to fit it in at the wrong place at the end, and we should have done it before we do the modulo. So we would do this. So score, oopsie. Oh no. Score plus equals the points component does -1 modulo 3. Is that right? Seems to be. What's interesting, though, is that we're getting a different result for number 2. So I'm feeling like this is wrong now. Because this is definitely not the right result. So, yeah, I have submitted now, so I should see the, 11.6.118. So let's see, what did I do? What did I delete, actually? Points of the opponent. Oh, 0 modulo 3 is 0, not 3. Why did I think it was 3? I don't know. The rest is fine, but this one is just like, this one is just wrong. Okay, but it's fine. Modulo 3, and then unless it's 3, unless it's 0. So in JavaScript, there's a nice little hack, because 0 is also falsy. So you can do something like assign either this number unless it's 0. Otherwise, do assign 3. And because it would evaluate basically, if you have 1 or 2 here, that would always be true. But then if it's 0, it would be false. And you could say, like, I find either this or 3, which is a super nice hack. I don't know if it works for Python. but I know that it's like this, right? But then, I mean, yeah, I could do it. It would be fine. It still looks better than what I had before. So we assign this if, no, I'm doing the other way around. I'm assigning 3 if opponent is, what is it? A, I think. Else this. I mean, it's still an if else. 11618. Yeah, that's the right result. Yeah. I mean, it's a one-liner. it's not bad. I guess it's yeah, it's all right. It's better than before. I think to me it was just like, oh my god, just Copilot just basically did half of the stuff for me. It was this was really scary, like the way that it kind of knew what, like, first of all, it just knew that I was playing rock paper scissors, and that, well, I told it I was playing rock paper scissors, but it just knew the rules. It just immediately just gave you the rules, because it kind of like suspected that you were going to implement it in some way. And then also, I mean, I'm wondering how much of this is coming from actually people playing Advent of Code right now. I could imagine that some people are using Copilot for Advent of Code, and then that is already feeding back into the system. So I guess it's a cloud service. Not quite sure. I don't think you have like your own version of it, your own model of it running in your own machine. That seems a bit overkill. But yeah, you need some kind of GitHub Copilot subscription. I have a GitHub paid account, so I was able to just use it. I just signed up for it. But I think it's in public beta or something, right? That's like version 1.16. Not quite sure. So I definitely would recommend for you to check it out. I do like the fact that you can, forget about these things like, oh, if else this and that, because that's just your busy work. You're just like writing things down, and it's nice that you don't have to like think about that, because it is sometimes hard where you're just like off by 1 errors could honestly be of the past with this, because these are things that computers are actually very good at and humans are not that great at them. So just like these kinds of small mistakes could actually be a thing of the past now. That would be super interesting, I feel. Yeah, that's pretty awesome. So I'm not, obviously, we're done now. We don't have to do anything else. I wanted to just start with tests, and I wanted to do a little bit with Copilot, and I've done all of that, and now the hour is over, so I think we don't have to figure out anything else to spend our time with. All I'm gonna do is I'm gonna add my work. Hold on. The -p, the -p thing where you stage hunks, only works if the file is already staged within, if GitHub Git already knows about your file, and it obviously doesn't. So I'm just gonna add everything that's day 2. Go, and then I'm gonna commit. I mean, I could spend more time and optimize some more things, but I don't feel I have to. I mean, it's really not that necessary. I do like that it's still good to read. I've used the list comprehension here. And today I solved the puzzle of today with like a really long list expression that went into like 3 or 4 levels deep, and that looks kind of okay, but it is a bit. I don't know, it's just hard to now. If you need to change anything about it, it's really tough to like figure out which parts you need to like take out and leave in. Okay, there's another comment. I think the second modulo only applies to the one after the negative sign as line legs brackets, but it makes no difference as we can just do points opponents -1 unless it's the case where you overwrite the value anyhow. Only applies to the one, this one, you mean? Is that true? Huh. Interesting. Could be. I mean, I don't think that's... Looks like you're right, so... Oh, yeah. Right, because we're doing this. Oh, yeah. We basically just moved stuff around into one line. That's all right. It's all right. It's not always about, like, you know, having a super elegant mathematical solution. If it works, if it's like not wasting a lot of energy or like compute power, I think it's totally fine to like write things out, do ifs and else. It's this is my opinion. The art of programming is like being able to talk to computers and humans alike in one language. Like writing software using a language that the computer can understand and maybe even in a way that's like efficient, but a human has to also understand it because humans have to maintain this. So yeah, it's not only about optimized machine readable code, it's also about human readable code. Yes, perfect note to end. Oh, thank you so much. So yeah, thanks for tuning in. I was amazed that it came out to exactly 1 hour. We will try and do this again tomorrow. As I said, I'm gonna try and do this like daily if I'm not out. So we will try to meet again tomorrow and do some more, which is like day 3, which is already getting a little bit more interesting, I think. And yeah, I hope you're having a good time. I hope you're doing Advent of Code yourself. And if you want to check out the repository, if you want to like just read through the solution yourself in your own time, in peace and quiet, then you can go to my GitHub. It's Leon Makes Things. And then this repository is AOC 2022. So yeah, hope you're having a great time. Good night, good morning, wherever you are. And I hope to speak to you soon. Bye.